Hey there, everybody. Welcome back. This is part 2 of Parametric Equations of Lines, which is 11.5 in our Anton book. This is Calculus 3. Let's just jump right into it. So we're going to do a couple more examples. We're going to find a line that passes through the point 1, -2, 4, and 2, 3, -4. So I want you guys to try to pause the video, see what you get for P1 to P2. Remember 1, -2, +4, 2, 3, and -4. Okay. So when you do it, when we're doing P1 to P2, we should be doing the end point minus the first point. So our X component will be the 2 minus the 1. We will have for the Y component 3 minus -2. And for the Z component, we have -4 minus 4. That's what I've got written right here. And we end up with 1, 5, -8. So that's going to become our velocity. This will be our velocity. And we're starting at, we'll say start at P1. So this will be our X naught, Y naught, and Z naught. So we can find the parametric equations, doing in each case our starting point plus the velocity times t. 1 plus 1 times t gives us our X component. -2 plus 5 times t gives us our Y of t. And for Z, we have our Z component starts at 4, and we do -8, our velocity, times t for that component as well. You might be wondering, where does this line intersect any of the planes? Here's a way you can find out, okay? The XY plane is when Z equals 0, okay? So let's go through and find when Z equals 0. If I say Z equals 0, I've got 0 equals 4 minus 8t. I can solve for t, and I'm going to get 1/2. So I can go over and plug that into X of t. 1 plus 1/2 gives us 3/2. We plug it into Y of t. -2 plus 5 times 1/2 is -2 plus 5/2. We add that all up, we get 1/2. So we should get the point that's crossing the XY plane is 3/2, 1/2, and 0. We could do that with any of the planes. If you want to do YZ, you set X equal to 0 and solve for t and see at what time does that little particle pass through the YZ plane. Let's take a look at another line or 3 lines. We got 3 lines here, L1, L2, and L3. For them to be parallel, they must be the same vector. So we're moving on to trying different things, not just finding the parametric equations, but seeing how lines relate. Let's see if any of these lines are parallel. So the first thing we got to do is find the velocities. And that's the the components that say t. So for line 1, we've got -1, +1, and -2, which we have here. For line 2, we've got 3, -3, and 6. Those are our multipliers on time. That's our velocity components. 3, -3, and 6. And then I've got -2, 2, and -4 right here. And now what you've got to try to do is see, can I treat one of these as a multiple of the other? So it looks like if I wanted to go from -1 to 3, I'd have to multiply by -3. Can I multiply all of V1 by -3 and end up with V2? Why, yes, I can. Can I go from V1 to V3? going from -1 to -2 is doubling it. So does my velocity double from V1 to V3? -1 goes to -2, 1 goes to 2, -2 goes to 4. Yes. We can write V1, V2, and V3 as all the same. They're all the same line or parallel. They're all parallel lines because they have the same velocity vector. Okay. That'll be it for this example, in this video. And I'll be right back with you. Peace.